Hi everybody. So today we're going to talk about the lab number 4. At the request of some of you about having lab on Wednesday, I'm trying to do my best of doing that. So the lab is going to be based on the 7-segment display. So imagine the following. I'm going to describe to you 7-segment display. We have an 8 digits of the 7-segment display on the board. How it works, you should have an encoder, and this encoder will be connected to time multiplexers, the one that you already built on the lab number 3. Okay, if you look to the 7th segment, you can segment it into A and B and C and D and E and F and G like that. And from there, you will be able to write numbers like 1, 2, 3, and 4, and 5, and so on. Okay, so what is the lab is today about? The lab is today is the following. I built already a code. I'm going to share this code with you, and let's go and see this code. Here is the code. So the code is basically communicating between 4 switches on the board. Four switches on board. Okay, so everybody can see that, right? So there is 4 switches here, 1, 2, 3, 4. Those 4 switches are responsible on displaying values on the 7th sig, which is already in front of you turning on, while the other 8s are off. You can present number here, and I made some mistakes in some numbers in the middle, so you guys will figure out how to solve it. Okay, so the code will be given to you. Then, you know, I use here the trick of the encoder send decoder that I would show it to you before. And inside this, there is some numerical numbers wrong you need to fix. That's number 1. Number 2, you will need to add in the top of the 7-segment display a counter. So this counter will have a specific functionality. I'm gonna actually just draw it later on the board after I show you some other stuff. So you have here the file. It's called SSD 7-segment display generators, and you have here the Nexus 4 DDR XDC files, and this is basically written based on the this file. I'm also gonna share with you, which is the Nexus. One second, Nexus 4 DDR XDC. So here, let me share with you the documentation. In a second. Manual, I need the manual. NX34 manual. So let me stop sharing here, and then I move to the share screen again. And let's into the manual. Here's our manual, okay? You will look into the 7-segment display section. I want you to read it, okay? You're gonna read it carefully. Let's see what. Here, so look, 7-segment display. I want you to read this section very well with the code I gave it to you. And then from there, so you're gonna read the section, and I'm gonna share this on the Blackboard, and you will go ahead and you will use the code I sent to you. And what is the task? I'm gonna draw it now in front of you. Okay, so the task is the following. Here is the block I made, which is a 7-segment display. Then there is a 4 switches here, and manually I use it in my current code. What you're gonna do, you're gonna connect it into a counter, and then those are 4-bit input. Then you're gonna have here the clock divider with 5 switches to speed up different 32 as we did last time. And that's gonna be the counter. The counter will be parsing values, and the parsing value will be going into the 1-digit 7-segment, as you can see. This counter, it will be what? That's gonna be a BCD counter. When I say BCD counter is what? That means count from 0 to 9. There is no more than 0 to 9. Okay, so the counter you're gonna build, you attach it to my 7-segment display. You will see where exactly you're gonna attach it. And then the clock, which is responsible on the counter, will be connected to a set of switches of the clock dividers. And those 5 switches will be responsible on how fast I will be able to see the counting on that digit. Also, you're gonna make a test bench for every single step you are making here. So test bench for the counter to see that it's actually performing BCD counter. Test bench for the clock divider. Test bench for the 7-segment display. I give it to you. And also you need to fix 1 digit, which is wrong in my code. So my code is counting 0 something something, and there is something in the middle need to be fixed. You have to fix it, and then it will connect the counter, and you will see what is the result. Are we gonna have any power constraints this time? Basically, we shouldn't have too much power constraints, but I will show you what I'm actually looking for. Here, with a 7-segment display, without counter anything, the total amount of power you already have is basically 0.104. I'm just using for lookup table for this digit. What I'm expecting for you, not to increase more than 0.3 power, total power watt. If you can work below 0.3 as a total power, that will be a very good target for you. Okay, so what we need the counters, and this counter will be up counter, and is a BCD counters connected to the circuit. I'll give it to you now, and you will fix the circuit actually, because you have to figure out where is the digit problems, and you're gonna write a test bench for my circuit, and every single circuit you can add, and also the total system test bench. When you're gonna deliver this, you're gonna deliver it on the Wednesday. If you have any questions, don't hesitate to ask, and I will be more than happy to assist you. The manual for the board about the 7-segment display also will be attached in a separate file with a compressed folder having the whole project there. Thanks so much for your time and your effort, and I'm looking forward to see your demo and presentation. Thank you.